x minus infinity minus null hypothesis divided by.
So the test statistic is just the p's, right?
Hey, I think so, yeah.
Hurry.
What is this? It would be 2.2 minus 0. So 2.2 divided by 0. Now how you set up that equation? We're still on 2, right? Or I mean 3.
Yeah, I don't know.
Well, I got 2. I'm not sure if that's right or not. But that's what I got. Right. So it's a paired sample. And so what it's like the D with the squiggle minus 0 divided by the SD divided by the square root of n. That's the equation that I'm going by. I'm plugging that in. I got 2. But I don't know if that's
Like, take that out.
sending that anything.
So where did you get that equation, Amanda?
It was in the video. So it said paired sample t-test.
Okay.
Then I gave that equation. It was in the, I think it was then the yeah, it was in the second video around like 3. Baby's crying.
Get used to that sound, Amanda. It never stops.
It's so sad to hear.
It is sad. I don't miss it though, I won't lie. Sorry, Randy.
It's fine. All day, every day.
Oh, I know it. Been there. What did you say you got, Amanda?
I got 2.
Okay, that's what I got too when I computed it, but I'm gonna try something on my little.
Don't mind me as I eat my dinner. You find anything different, Lisa?
Oh, I'm just trying to plug it in to the program and see if it shoots me out any numbers.
Amanda, which formula did you say you're using?
The paired sample t-test. So it's the d minus 0 divided by SD divided by the square root of n.
So that formula was in the second video?
Yeah, around minute 3. At least I hope that's the right equation to what we're trying to figure out.
Using that, I get 2.
Yeah.
That's what I got too.
Did you try anything different in the SPS?
No, I'm still just. I think that one might work. If it's wrong, I mean, obviously we'll change it. But I'm just trying to. I'm afraid there's going to be more answers that are going to require that, and I'm just trying to figure out how to get it set up in there so we can use it.
Okay.
So we can go on to number 4, though, if everyone's okay with putting 2.
And if you guys trust me. Okay. I mean, the numbers seem like pretty simple. Like they're not like point blah 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 like they have.
That's what makes me leery about it, though, almost. Which is terrible, but I'm like waiting for the trick.
The probability of obtaining is greater than. Huh. I don't think I have a. Or are we just using? No, I don't. Would this be like along the lines with like 100% confidence interval formula, or I don't know.
I know it's thrown me off where it's already kind of giving you a probability number. Remember.
Okay. So I do see something in the second video, around like minute 5.5. It has the calculated t-score, which we have, I believe, right? That one guy? Yeah, the test score, the test statistic is 0.0403. And then determine the degrees of freedom. And then somehow we're supposed to find the p-value. So the video doesn't have a very good example. Actually, but,
Neither does the book.
Yeah, that's what I was thinking. I haven't really found anything either, but
so he has the calculate t-score, and then he has that, and then he has the degrees of freedom, which is 12. So our degrees of freedom would be 8. That's n minus 1. But I'm not 100% sure how they got 72.
That's a new one.
So we can just cheat and maybe there's like a calculator for p-value. Okay. Um, should we just move on and come back to it later?
Yeah, probably. It's hard because the help we're given, like in the book and the video, is using SPSS, but here, I don't know how to use. I guess I don't know how to do it without SPSS.
Yeah, that's what my same problem was, and I tried it, it didn't work. So, yeah. Hopefully, if we move on, maybe something will.
Okay. Let's go to 5, I think it is.
I'll figure it out.
Okay, so here, you have to open it. Let me see if I can. You can do it.
Okay. Shh. You need to get some pants on if you're going to go outside, not shorts. It's too cold.
Say, is someone else there where we going? Is someone else there where we going?
Have any of you guys plugged it into the SPSS yet?
Not yet. I'm still trying to convert the file.
Yeah, I haven't yet.
We're doomed. my gosh. Lisa,
Huh?
you have the numbers pulled up
I
the-
do.
from the data file. Just write them down.
I can't guarantee you that they're right, but I followed the directions from
No.
the left.
No, but just like the
Oh, the actual numbers. Oh goodness, there's there's only 20 of them, I guess.
Can you copy and paste them? Does it let you? Because you can just copy and paste them in this little group chat, and then I can just get them down.
So do you want just the two groups that it gives you, or do you want the difference that I figured as well?
Just like what's in the file. I can't
Okay.
open it.
Both those are really close together, but
So I'm kind of frustrated by
right.
4. It's a lot easier than I was trying to make it out.
Oh, don't say that because then I'm gonna feel stupid.
Yeah, you will. You will.
Yeah, I'm gonna.
So,
All right, what?
So it gives you the probability, which is 0.0403, right?
Right.
Plug that into the applet, and then you highlight just the left side because we want the probability of someone obtaining it greater than him.
Can you do that with the test score versus the X or
Well,
Z?
no, because all you're doing is using the probability. That's why you're using the applet. So you use that 0.0403.
Oh goodness.
I know.
Oh my god. Okay.
I feel dumb it took me that long, but
I'm sad that you're the only one that figured that out.
yeah. Anyway, so I got 0.0228.
80228. But it's the 3, right?
What was that?
Is it 3 decimals or 4?
Oh, 3. Yes, please.
Well, way to go, Randy. Way to take one
Well,
for the
I'm glad
team.
you figured that out because I was still like, how are we going to figure that out after we get through all these other ones?
Yeah. But now that we can use the data files in SPSS for the next ones at least.
Yeah, well, yeah. I've got them all pulled up and calculated, and it went pretty smoothly, I think, if I did it right.
Okay.
If I did not, don't blame me. Okay, I'm just kidding. You can blame me. Okay, sorry. He's being so loud, but he's going to go in a minute. Let's see. Okay, so I have them both pulled up, so I need to figure out which one was the first one. I think it was this one. 20 of them. Okay. So what's the first question? Okay. Okay, so let me just see if I did this right. So I pulled it up and I computed the variables and minus group 1 from group 2 to get the difference column. And then I just did a one sample t-test on the difference column. Is that how we're supposed to do it?
Yes.
Okay, that's what I thought, and that's what I did. So I'm hoping these numbers are right. Okay, so for the test statistic, which is just the t-value, right?
Yes.
It is 0.407. Goodness, guys. Okay, so now the p-value for the next one, because the hypothesis equals 0 and the alternate hypothesis does not equal 0, we have to do both tails, right?
Yeah.
Okay, bye-bye. Bye-bye. Okay, so that number then would be, okay, 0.689. Bye-bye. You'll come back. It's fine. Oh. Okay, so
What's going on?
our area of significance is 0.1.
The point of significance is 0.01.
0.10. It's a little bit higher than what we've normally done, but our p-value is 0.689, so it's still quite a bit higher.
Oh, right. You're a genius.
I try.
So, man, the baby's getting like crazy right now.
Hey, can you go watch a movie for a minute? Those are really loud. On 7, we're failing it, right? Failing to reject. It's above.
So the p-value is less than a. Reject.
Yeah.
So failed to reject.
So I don't have a lot of them, so I overthink it. Okay, so on 8, if the alternative hypothesis was greater than 0 instead of not equal to 0, then our probability is going to change from 0.689. We're going to divide that by 2 because we're only talking about one wing. And it's still going to be 0.345, which is still higher than the area of significance. Correct? Everybody agree?
Yeah.
What was that last part you said? Sorry.
Which last part? So I'm just on question 8.
Yeah.
So what we did in the last lesson was if it's not equal to 0,
Yeah.
then we do both tails of the thing. And so you take the whole probability number that it gives you in the SPSS. If it's greater than or less than, you divide that number by 2.
Yes.
Okay, perfect. So then if we divide 0.689 by 2, we get 0.345, which is still higher than 0.1.
Mm-hmm.
So which of these do we think it is? Because we are still going to fail to reject the null hypothesis.
Want to be the third one? Yes, sufficient evidence of the mean of the difference is greater.
I thought it was the fourth because the null hypothesis is that it's equal to zero,
Oh, yeah.
right?
Yeah.
Because I put that the first time and then I had to rethink it.
Yeah.
Okay.
Thank you.
So, and this next question, I'm sad that I actually looked up the numbers just so you know.
For 9.
Yeah, 9, I pulled up the second chart that it gave us,
Oh yeah.
but it's asking which value is greater, n or the df or whatever.
Yeah.
I can't even remember what df stands for now. It's the degrees 1. I think.
Yes, it's doomed to fail. That's great.
You think the degrees of freedom is greater?
Oh no, I was. No, so n would be greater because when the degree of freedom, you subtract it
1 less.
Yeah.
So n would be
So it's n is greater.
I was just making-
Yeah, I was getting confused there, but
I know it. I actually looked up the numbers, you guys. It was terrible. I should have known better. Okay, so let me double check that I set this one up right. I believe I did, but yeah, I did. So for the, I don't remember what the first question is. Okay, p-value, and it is not equal to, so it's going to be both. The p-value is 0.001 is what it's showing me for this set of numbers.
Okay.
So on this one, our area of significance is 0.01.
P value is no it reject. Right?
What was that?
It'll reject it
Yeah,
because
I
P is
believe
greater
so.
than
It's
less.
smaller.
Let's say it would end. Or
Are you guys on 12 as well?
In 12, I put decrease.
Decrease?
Yes, because when it's greater than or less than, you've got to divide the number by 2. In the last one, it went from 0.689 to 0.345 when we switched it.
The p-value.
Mm-hmm.
Okay.
Does that make sense?
Yes.
But if it were to be the other way around and it were asking us to double it, then it would be an increase. But in this case, because we're dividing, it's going to decrease.
Yeah.
So it's going to be like 0.0005, which is really little.
And so 13 is still reject, right?
Yeah, it's still smaller than 0.01. 14 is the one that I hate these ones.
You have to read each one so carefully.
I don't know, it does not click in my brain. You give me any math problem, I can solve it, but don't give me these.
sorry, did you say something?
What was that?
Did you say something?
I don't think so. I think I'm talking to myself if I am.
Oh.
I'm just trying to figure out. Yeah.
Oh, what a little stinker pot. That's so annoying. Mm.
Do any of you guys have a guess on what you think it might be?
So I would think it's the last one,
Mm-hmm.
but
That's what I was thinking.
going off of our answers that we gave.
Yeah, that's kind of what I was thinking, but I'm thrown off by, I don't know, the way they're wording it. So I guess let's try it and see.
Okay.
I know I have a second guess. So on this last one, this is the one that's totally messing with me, just so you know. Because what I've been doing is the greater than and the less than are supposed to be the same p-value, because obviously the not equal to 0 is a bigger number than those two. So I'm not sure. Because I just read, and that didn't help me either. It pretty much told me the same thing. Because it's going to be the same, I think. What do you guys think?
What's
I know
this?
it's not the first one.
I think me personally, I think it's either because I have written down here, the funny u less than 0 or the funny u is not equal to 0. In my notes.
For what are those numbers for that you have written down?
I don't know. I don't remember. Go back to where it was.
Well, because if you think about it, if you were to plug it into an applet of, or that type of thing, because it's talking about the two tells, if you add those three up together, it's going to cover the whole thing.
Yeah.
So it's going to be one, maybe it's not enough information, depends on the problem. But I don't know, that doesn't make sense either, because I don't know, maybe I have no idea. We can guess, maybe.
Is this test two-sided or one-sided?
It depends on your alternate hypothesis. So,
Maybe the third one depends on the problem.
and that's kind of what I'm leaning towards because none of the other ones, I know it's not equal to, and the other two don't make sense to me.
Yeah.
I would,
So
to me, it just depends on the problem. So
yeah, that's true.
the only thing that was kind of throwing me off is where it says not enough information. But
Yeah, that's throwing me off too.
the bigger thing here is depends on the problem.
Right. I think you're right.
Is it in the video? It said that not equal to is for a paired test. But I don't see anywhere where it says it.
What was that?
In the video, it says like a two-sided test. But it would be if it was a two-sided test, it would be the not equal to. Then everything else would fall under the one. I just wanted to see what kind
That's why I think it just depends on the problem.
yeah.
So let's put that one down and see what it says.
Okay.
Did you have SPS set?
I do, and I'm confused because what is the point estimate?
Point estimate.
That's a stupid question. It's just I'm like not getting it tonight because it's
Oh,
yeah.
that's not specific.
Does that mean it wants both?
Well, it wouldn't make sense. But, well,
I don't know. I'm just confused by the whole what's the point estimate. I have the intervals.
so it's the parameter of a population. I think this was just solve that last week ago.